Okay, I believe we are live. My streaming software nearly broke and didn't work at all. That was a fun panic mode just before we really got started. Ugh, not what I needed, but that's okay. Tonight, we are continuing to look at Keras, a machine learning library that is, again, a wrapping language around Theano or TensorFlow. Last time we did some very simple introductions, very simple, and you can debate how simple they were. We got through, looks like, about 60 lines of code of looking at stuff. We went through the typical MNIST example, because that's what we do. We love looking at MNIST, it's super good. Hang on, are we actually working here? That is the question. It says I'm live, but am I really live? Let me test something out. Pardon me one moment. Okay. Yeah, we are working. Okay. Sorry about that delay. So tonight, we are going to look at trying to implement a custom activation function for Keras. You can do this in Theano, sort of, that's built in and easy to do. You can provide arbitrary activation functions. Keras, however, if you recall, when you do the model.add, you specify what kind of activation you want. And so you've got things like sigmoid. I think there's in the latest Theano that came out, there's like ReLU and other stuff, and Keras has all those available. And there's even these advanced activation functions that we're going to take a look at. Let's take a look at that right now. Keras advanced activations, perfect. Advanced activation layers. So they have a couple extra ones available in Keras, but they don't say, oh hey, here's how you can add an arbitrary thing. Is this more than even last week? I don't even remember. So, but I want to be able to say, I have whatever I want. Because, you know, machine learning is moving very quickly. Someone's going to come out with this, oh, this particular activation function is exactly what you need. And I don't want to have to wait for the developers to implement that, because inevitably I'm going to want it yesterday. So let's check out how we can actually get that. I believe we found out where some of these were implemented using a custom class. Let's look at that. So we're going to Keras GitHub page. We're going to go to Layers, Advanced Activations. We're going to look at if there's a regular activations here. There's not. Okay. So we're going to look at this Advanced Activations business. And we're going to try to copy this structure in order to get our own kind of activation. So first, we should just grab that file and make sure that we can use it properly. Excuse me. And I think, how do we actually use advanced activations? Keras.layers, advanced activations, whatever. So because we've installed Keras, we should already have all these advanced activations. Let's see here. I gotta import Keras. I gotta import just Keras properly. Let's make a new line here. Import Keras. Yep. 0. So remember, this Keras has no attribute layers. Oh no! Import Keras.layers.advanced activations.leaky ReLU as, I'm just going to call this LRLU. Can I do this? Okay, I can. It looks like it anyway. Blah blah blah, talking about my pathetic graphics card. Always a little sad when I see that. Let's go, let's go, let's go. Oh, importing Theano. It always takes time. No module named, whatever. Alright, here's an interesting question. How old is my Keras and how new is advanced activations? Latest commit 6 days ago. But this stuff has been around 15 days, 2 months, a month. This stuff has been around, surely. Surely. let's look at the history. On GitHub, I'm looking at the history of this particular file. It's been in here for a while. So it definitely ought to exist. The advanced activation layers really ought to exist in Keras here. No, Keras.layers.advanced activations is not a package. That's so sad. Let me just poke around in my actual installation of Keras here and see what we got. Layers. What do you know? Advanced activations right there. Turns out you were wrong. Unless I misspelled activations. Advanced activations. Alright, so I don't know why I can't find it, but that's fine. I don't really care about that. Alright. I'm going to copy this file, because I don't want to screw around with the existing file. Put this in my proj/Keras / we're going to call it custom activations. Activations.py. Okay. We're going to open up that file. There's going to be some things that we can't, things that we have to change here, because they're importing interesting things from like masked layer and none of this, and they're using this Python 3 kind of syntax of from ... which I don't really like, but I get it. I want absolute imports as an option. I want to be able to import a file. I've written like wrappers to do this in Python before, but alright, because if you try to do this, it's going to yell at you. It's going to say, what are you talking about? Yeah. So we just need import keras.layers.initializations. Yeah, there we go. So from keras.layers, there we go. And from keras.layers.core, and from Keras import backend as K. K. Interesting. Import numpy as np. Okay. So my goal here is to change one of these and do something that I can really use. So here they've got this like leaky rectified linear unit, and that's fine. That's great. Isn't like relu 6 something? Keras.layers.activations. Yeah, and there's relu, which might even have options. Max value. Okay, so they do provide some customizations to it. And they got tan-h. They got all this other stuff. Alright. But I want an arbitrary custom activation function. I don't wanna wait. So we're gonna take one of theirs. So what we learn is that we have to define a special class here called leaky relu or whatever. Let's just copy our own. Let's just change it. Let's call it funky. And we're going to import from masked layer apparently. This is a special. This is not a special version. This is now a funky version of rectified linear unit. And for the moment, I actually want it to be exactly the same as let's say like the leaky relu. So leaky rectified linear just means that when your input value to the function is less than 0, you still pass through a little bit. The typical, let me draw a dang picture is the easy way to do this. Open up GIMP. Make this understandable. New, yeah, whatever. It's a picture. So standard leaky relu is going to be something like this. Oh gosh, that's awful. Hang on. I don't want to airbrush. Something like this, where this is the XY axis. XY is over here. But in your, let me draw my axes back in. In leaky relu, you do leak a little bit, even though your output value is going to be less than 0. Your input value, excuse me. So you still get some value. Maybe that's important. Traditionally, rel_u is just like you wipe out. You say this feature isn't here at all, so I don't care. Or like if it's here, like I want to know how much it's here. And then you can have rel_us that have some maximum value. You say, well, if it's more than this, I don't care how much more. Anyway, that's a small diversion. All right, so what are they doing here? They're using Python. They're inheriting from the masked layer class. So that's keras.layers.core.masked_layer. If your layer trivially supports masking by simply copying the input mask to the output, then some class mask layer instead of layer. I'll be honest, I don't know what they're getting at when they say that. Do all of these things support mask layer? Mask layer, mask layer, mask layer, mask layer, mask layer, mask layer, mask layer. Okay. So here, when you say super, this needs to be funky. Funky. So we're sort of using the class itself, how we initialize it. There's some alpha, negative slope coefficient, right? So the slope of that line below 0. Get output. We say x equals get input and k.rel_u. So is this not actually... Does rel_u already have this built in? Alpha equals alpha. Yeah, that's helpful. That Keras needs a little bit more doc strings to make this wonderful. You know what? Make our own special activation layer, maybe. No, we'll start with it just being as is. Name config self.class.name alpha. Again, not super leaky rel_u, super funky. Okay, I just want to see if this works at all. That is what I want to have happen. And then how do you actually use this? Do they have an example? They really don't. Keras advanced activation example, maybe? Keras advanced activation example. Because so normally you would say from whatever import. Does this work if I want to? That works. Alright, so I just want to say from custom activations import funky. Hey, what do you know? Funky is a thing. Alright, let's make a stupid model just to try this. See if this even runs. Alright, so here's a stupid little model. Let's, just for the sake of argument, say it's leaky rel_u. Let's see if this even goes. Sequential is not defined. Right, because I haven't actually imported those things yet. Cannot import clear previous. Right, we determined last time I don't actually have that. Which is unfortunate, but the way things go. Alright, now we're ready. Make our model. Dense layer as usual. Let's try leaky rel_u. What happens? Invalid activation function. Right. How do I like register it as an activation function? If it's all lowercase. Let's try that. If somebody knows the right way to do this, feel free to shout out and make me look like an idiot. Or if you think I'm already looking like an idiot, feel free to shout out and confirm that. The advanced activation layers. How to use advanced activation layers in Keras? Yeah. I use other activation layers like tanH. Pre-LU not available. Where's he using activation soft plus, soft max, ECT? Oh, interesting. He imported it that way. The correct way to use it is with add. Oh, interesting. Okay, so I need to So I did this a little wrong, I guess. Alright, so I should be able to say leaky rel u this, act 1, act 2. And this will be funky. They ought to give me the same thing, right? Yeah. Act 1. Ooh, keyword argument not understood. Weights. Alright, let's undo weights then. There's no weights here. None at all. Is that fine? Keyword argument not understood, isn't it? You know, I would have thought it would go in order. Let's do this. Let's do that. Okay. And then I say act 1. I'll just make a new model here. And that did something. Alright, let's grab my data here just to make sure this is all above board. That is doing vaguely what we expect. Let's compile this. SGD not found, of course not. Let's make our SGD. Alright. Alright, that was 15 seconds. Not bad at all. Not bad at all. Let's do the fitting business. Let's enjoy the progress bar, prepare ourselves. Superb. Our accuracy is up to 89% with the leaky rel u there. Just kind of an arbitrary thing there. That's fun. W1, B1, W2, B2. Okay, so that seems to have done about the correct thing. I want to see what happens. Replace this with funky, our own custom, and by own custom I mean a re-implementation of the exact same leaky rel u. Let's go with that. Recompile like we're doing before. All we did was change. I'll compile a lot faster. Probably that's just caching. Running as before. It's not crashing. This is an improvement. And we're not going to get exactly the same accuracy just due to random fluctuations. But it seems to have done the right thing. Just W1, B1. Okay, that did things. Alright, well that's interesting. Okay. Here, however, we just did sort of k.rel u. I bet the k backend. Keras import backend. Oh, backend is whatever. So I'm using Theano as my backend. So it's saying, hey, call Theano's rel u here. But I could sort of do whatever I wanted there. Interesting. So that actually seemed to work, but like I don't know, I assume all this git config stuff you have to set up special. Like what are the options you can pass it? Apparently alpha is an option you can pass it. When you initialize it, you have to pass it these things or give it other optional things. But this get output is sort of the key here, and I guess train is what they're calling the input data that's activating it, which I think is kind of strange. I wouldn't really call it train, because you're going to be activating it with testing data too. But that's okay, that's not a big deal. Honestly, I expected this to be much, much more of a headache, but granted, I haven't actually changed anything yet. So what is a good let's ask the internet. What's the hit new activation function? Neural network new activation function. I called it funky and it's a function. I like that. I didn't even think about that. Maybe latest? I'm looking for an esoteric, a Gaussian, multi-quadratic. There's lots of options here. Inverse multi-quadratic? Surely that's something that you want to use. comparison, nonlinear. All right, here's some good ones. Do we not have the identity activation function actually? That'd be interesting if we didn't. Activations, usage of activations. I guess linear is probably the same thing. You can just pass in the slope. You pass in the slope of 1, you get there. Parametric rectified. Oh no, we have that. Arctan. I don't think we have Arctan, do we? Advanced activations. Let's take a look. Do we not have Arctan? Arctan. I don't think we have Arctan. All right, well let's implement the Arctan. There's soft plus, there's bent identity, soft exponential, sinusoid. Some of these things make more sense than other things. Arctan, derivative is monotonic. No. That could be troublesome. We're gonna find out. Binary step. Oh, that'd be good. Good times. This picture is imperfect. Look at that. It's not a binary step. There's a slight slope there. Whoever drew that picture. Oh, bad news. Bad news. Okay, so Arctan is just literally the inverse tangent kind of function. If you took geometry or algebra recently, and I believe NumPy should have it. NumPy.atan, Arctan, and Arctan itself. There we go. Wait. There's Arctan and there's Arctan2. I gotta remember this. What's the difference here? Element-wise arctangent of x1 over x2, choosing the quadrant correctly, as opposed to trigonometric inverse tangent element-wise. I think that's the one we want. So here they're using this k, right? Import Theano dot. The thing is, NumPy probably doesn't work on. I'll tell you what. Let me just try it. NumPy probably doesn't work on a. Woo! That's not what I wanted. On the tensor objects that Keras and Theano are going to use. So if I say something like numpy.arctan of x, for the sake of argument, let me try reload. Let me just screw it. Let me just redo it myself here. Auto indent. So I'm no longer even getting rid of some empty space here. That's just for Slimux thing when I send it over. Okay, much better. Now I have funky again. Time to get funky. So now I'm no longer calling a Theano backend. Now I'm using the Arctan. And I'm not really using the alpha, but I was never using alpha, so that's okay. Now I want to see what happens. Does he yell at me? Doesn't yell at me. See if he yells at me when it tries to compile, because it's going to say, whoa, buddy, I don't know how to compile that. That's some NumPy thing. Let's find out. This is where I would expect it to yell and maybe choke, because I haven't defined it using Theano pieces. I've defined it using NumPy. It worked, though. Can I fit, then? Interesting. That actually worked. I'm also amused that, like, this isn't the horrible Act 2? Act 2 dot. Oh, Act 2 is a layer, so it's got all the layer things that you can do. Dot name. Funky. Interesting. Okay, I did not expect that to work. I was fully expecting that to throw things in my face and be all. Alright. Wow. Theano dot. How did I do this with Theano? That's the real question. cd_Theano. What did I do there? Because I could have sworn I defined my own stuff somewhere, my own activation function at some point. Because like I didn't have ReLU or something. What's MLP? Oh, that's their own. My CNN maybe? Def floatx, init waits, rectify. Yeah, and I use my own Theano functions. What do I use T? Theano.tensor. Alright. I think it'd be better to do that. Import Theano.tensor as T. There we go. T dot, alright. And does T have like an Arctan? It does. Okay. So rather than numpy.arctan, we're going to use T.arctan, tensor.arctan. Although it's super, and this is probably using numpy in the background, maybe? General, well, maybe not. So here we go. Now we're using proper Theano. So that is one catch. If you're defining your custom activation function, you will probably want to do that. Yeah. You'll probably want to do that with actual Theano or TensorFlow primitives to ensure that you get maximum speed. Because when I say whatever numpy, I don't know like if it does the smart thing and it replaces it with Theano automatically, or I could just use straight up Python. That's probably what I'm going to try next. This might end up actually being a short video. Just because things are surprisingly working out. 1.56 seconds. Did it take 10 seconds to compile before? It did take 10 seconds. Interesting. Again, could be cache stuff, could be actually fast. This feels faster too. This looks faster. So I think probably the numpy is not as fast, but it will work. Let's do something with pure Python. Import math dot. Oh yeah, math.arctan. That's what we're gonna do. Can I see? No, that's still not that slow. Import math. I just want to keep around my various versions. Return math.arctan x. Oh, this may yell at me because I'm sure math.arctan x doesn't actually doesn't work on arrays. Right, so if I say a equals numpy dot numpy.random dot rand 1,10, so I get 10 numbers here, and I say yeah math.arctan a, it's gonna yell at me. Right, only length 1 arrays can be converted into Python scalars. So if I said A0, it would do, really? I could have sworn A of 0. Oh, I see. It's an array of, that's weird that it's a two-dimensional array. A.shape is going to be like 1 by 10. Yeah, rather than just being 10. Didn't expect that. Oh, I'm an idiot. If I say that, that's, yeah, I confused myself. I thought I was setting the upper bound on my rand, but that is not what I was doing. So if you say, again, but you say multi.arctan, math.arctan, that doesn't work. You have to pass it a number, and then it knows what to do. So I'm fully prepared to see this blow up in my face. So you need something that works on at least arrays. I bet is what it is. Because we redefine funky, we make funky. So it might say, oh yeah, I'll do the activation, sure. This really, yes, blows up in my face. Because when it goes to get the output, it's like, hey, I need a float. And you didn't give me a float. In fact, what does it give you? What is x in this case? X is some strange construction, lm-wise. What is x? It's a Theano tensor dot variable. Because it's doing the symbolic computation, it needs to get the derivative of everything. So if you can get something that can handle an object like that, you can do an arbitrary Python thing. In my experience, however, if I can do this with NumPy, that's going to be good enough. I want something crazy here. NumPy.arctan plus. Yeah, logistic, soft plus, benta. What's easy? Cosine. Oh, sinusoid. Perfect. Arctan plus sine. And NumPy.sine is almost certainly a thing. NumPy.sin. Yeah. So now we're just inventing crazy activation functions just because we can. Let's do that. Redefine that. Make our silly little function. Do this, yada yada. See how slowly that compiles. Probably 10 seconds again as usual. Maybe 15, 20. Come on. You can do it. You can do it. We're throwing air. 10 seconds, yeah. So it's slower to compile with NumPy. Probably because it's got to do this substitution. It's like, hang on, what's this thing? Let me get this. Let me fix that. Okay, fine. And it looks... Doesn't it feel like this runs a little slower? I mean, I could time it properly, but... 1 second, 1 second, 1 second. I bet the other ones are all 1 second, too. Ooh, that's not what I wanted. Yeah, I imagine it is all 1 second, 1 second, 1 second, 1 second. Yeah, alright, it's about the same. And, oh hey, look at that, our custom activation function doing so much better. Clearly, we need to publish a research paper that the best activation function to use is arctan plus sine. Actually, interesting that linear combinations of activation functions. That's just like having another layer of your network with weights all equal to 1, right? And it was though on this layer, these nodes have this activation function, and these other nodes have this other activation function, and the weights going to them are the same. So that's probably a thing that already exists, so we don't have to worry about that. Okay, that's all I wanted to do. I mean, we could futz around and do like a convolutional neural net. That's not hard. In fact, let me whip one out real quick. See if I can do this in like 5-10 minutes. 20 minutes later, I'm going to regret this decision. Convolutional layers you can do, of course, with convolution 2D. Let's use the same activation because that's clearly working pretty well for me. So model.add Is there a tutorial actually that might make this a little more straightforward? Alright, let me search the internet because I don't want to have to. Keras convolutional layer. No. Example. There are a bunch of examples in here actually, if I recall. Keras examples. There we go. Cipher 10 CNN. I mean, whatever. MNIST transfer CNN. MNIST CNN. There we go. Yes, you gotta do the usual stuff. And in this case, I have to fiddle with my data too. Specifically, I don't want to reshape it, right? Let me just kill this. Do this the kind of easy way. Convolution 2D. There we go. I'm not retraining convolution 2D, evidently. Convolution 2D? It's not. Oh, layers.convolutional, really? So yeah, finding the right thing to import. Keras.layers.convolutional import convolution 2D. Figures. Figures. We got this. We're going to change the type of everything. Divide by things. Do this, do this, do this. Okay, now we've got our sort of our two-dimensional business. Let me kill that. I'm just going to steal their line here. Because I'm a terrible person, and that's okay. I've done this particular tutorial before. Whoa. Set paste. There we go. That's better. So the number of filters, that is how many features you're extracting from your small window. So let's say 3, I think is a typical thing to do. Maybe more. Whatever, we'll start with 3. NB_conv. Convolutional kernel size. Did I get this confused? No. Oh yeah, so they're doing 3x3 windows. Right. Oh boy. Alright, so 32. Let's change that. 3x3 windows. Our input shape is, of course, 28 by 28. Xtrain. That shape. Yes. Okay, good. It might freak out a little bit here. And then you gotta flatten after you do this stuff, as I recall. That is the catch. And we can do some max pooling, and we'll throw some dropout in there too, just for giggles. And another dense layer, why not? Why not? Why not? There we go. Much better. Right? Yeah. They do convolution activation pooling. Right. Alright, so I had that right as I did before. Pool size. Our pool size is going to be 2x2. We'll drop out 1/4 of the time when we're training. Then you can just call flatten. This is nice. So you've got this sort of 2x2. You've got this n by n by number kernels, number features. Filters is the word, excuse me. This n by n by number filters array. Flatten just says, nope, flatten that all out. Give me one long, one-dimensional thing so I can feed that into another array. Feed that into another layer. Let's say, I don't know, 32. I like 32. 32 is good. This should good. The only thing that concerns me, this is 1, 28, kind of 28. The 1 stands for the number of channels of input. And we've only got 1 because it's gray, but I haven't actually made that clear in the numpy array of Xtrain. That's what I was looking at this here. If it was 60,000, 1, 28, 28, we'd probably be in a better shape. And in fact, I think I better take care of that. I really should just take care of that right now. So we are going to reshape it to be 1, 28, 28, 1, 28, 28. There we go. That should be fine. Dot shape. No, hang on. Let me read that data in again, and then do this. There we go. Better. Interesting. 0. Okay, there's stuff there. Yeah, there's things. Yeah, okay. Yes, they're all in the range of 255 or something. Did I did not. I only reshaped this. Okay. There we go. Now we're ready to build our model. We've got a layer of convolution here. I like it. That's right. I have multiple layers. I have highlightception. Oh no, what did I do? We got a convolution layer here of 3x3 windows, pulling out 32 features. Then we're going to use our super special activation function, do some max pooling 2x2. So we'll take the output of this convolution and just sort of, out of every 2x2 box, take the best one. That's the max pooling. A quarter of these things we're just going to forget about while we're training, just so we don't overtrain. Then we flatten that back out so we can put it into another layer, typically a densely connected layer, with some normal activation function. Whatever, you can do that. And into our final output layer with the softmax. Let's do that. See if this blows up. Uh-oh. Something didn't go well. Max pooling 2D is not defined. Right, because I didn't actually import it, because I'm a terrible person. Where's max pooling? No. Alright, so it's in the convolutional layer. So Keras.layers.convolutional import max pooling 2D. There we go. Okay. Let's go a little bit at a time right now. Got our convolution, got our special activation, max pooling, dropout, flatten. Flatten is not defined, because flatten is a core layer. This is why typically I just prefer to say import Keras, and then I would do Keras.whatever, but the tutorial had it going another way, and I think some of that doesn't even work. You have to do a from import, which I don't like. But in general, Keras is otherwise pretty nice. Okay, do an SGD. Let's see how long that takes to compile. It might be a little longer because it's a slightly more complicated neural network now. We have more layers, more parameters in those layers. Hopefully, it doesn't take forever though. What is our... I have to make sure to look at what our actual funky thing is doing. It's numpy.arctan plus numpy.sine. So it's going to take a little bit of time. I should have checked if I could have done theano.sine. That might be faster. Compiling takes a while. Take a little bit longer here. Okay, 51 seconds. Wow. Alright, let's just try this model. Oh gosh, that is slow. Whew. There's a lot more parameters that we're trying to tune over. So that's got another 20 seconds. Alright. Let's change that to 1 epoch. Hang on. There we go. And let's say t plus sine of x. Alright, we're just going to let this finish for another 10 seconds or so here, as I hopefully made a Theano version. I don't recall if Theano includes sine. I imagine it does. 3, 2, 1. Big rocket, go now. What is our accuracy? 92. Look at that. So good. That's not actually super surprising, because with the convolutional layers you can get general features in a localized area and expand those out to a larger area. Get weights. What is this? All our things. List object? Oh yeah, of course. Okay. Import theano.tensor as t. Okay. T.sine? Is that a thing? It is. Okay, so now we've got a pure Theano version of our sweet activation function. I'm going to... Woo! That's not what I wanted. I'm going to formally just copy-paste that over. Do you want to paste code in whatever? What? Def init. It's not happy about. t dot sine x. Let me retype this. That shouldn't have been. Oh, my auto indent is off. There we go. That's the problem. If you're pasting things in Python, make sure to turn off auto indentation. Name mask layer is not defined. Well, it is now. There we go. Okay. So we've created funky. We've created this. Let's create our model again. Let's see if this is faster. Probably it's a cache thing again, but that's still faster than 10 seconds. That's so much better. Now, is it actually any faster to run though? No, not really. I mean, it's taking about 30 seconds to get through an epic. So I think Keras / Theano is just doing the right thing and converting the NumPy into proper Theano code. Of course, you can do the same thing with TensorFlow. I might do another video next week on using TensorFlow as the backend. I mean, it's basically going to be the same thing, just to show you that you can do this. It's not impossible. It'll probably run slower on my machine because I haven't gotten TensorFlow working with my GPU because my GPU is really old. Man, this validation accuracy, still pretty good. Pretty good, pretty good. Model out get weights. Still a thing, still a thing. Okay. So I think that's all we're going to have tonight. We're actually going to quit early because things worked pretty smoothly. So, of course, we went over basic convolutional models with Keras. Again, you've got convolution 2D. There's a convolution 1D and a convolution 3D operator as well. They work pretty similarly. And, of course, you can chain these various convolutions to the next, to the next, to the next. But more importantly, we learned how to make custom activations by stealing their advanced activation and just changing the output. Note that you also need to change the name in init here and in the config. And if something does or does not have some special parameters that it can take, like this alpha value, which we're not actually using, you need to add those in here. Act2.name funky. And so we did that with our own custom activation function. We trained this neural net with arctan of x plus sine of x, because that makes perfect sense, right? That's a good one. I can't believe that even worked as well as it did. I guess it's just not that sensitive to the activation function, which is interesting. So on a problem like this, maybe. All right. So everyone out there should have a good night. I'll be back next week, I think, for some more Keras. We'll try Keras with TensorFlow.